Okay, so now let's continue our review for the Unit 4 lecture exam in geology by talking about what ice can do. So this is going to be lesson 18. So here's your lesson objectives for this lesson. And then this corresponds to chapter 18 out of your textbook. And let's talk about where do you find glaciers. So there are two kinds of glaciers, continental glaciers and then mountain glaciers. So the mountain glaciers are going to be shown in brown, and then the continental glaciers are shown in blue. So in those mountainous regions, the elevation is so high that it's going to be cold enough that water stays frozen up there all year round. So how does a glacier form? So glaciers begin as snow. So when it snows on the ground, it then snows more. And when that snow falls on this snow, it gets compacted. And so it can get compacted so much that the ice crystals interlock with each other, and then you get a very, very dense kind of ice. And that's what glaciers are composed of. Okay, so again, here are the two different types of glaciers, mountain glaciers and continental glaciers. Okay, why do glaciers advance and retreat? So I want to point out that a glacier always goes downhill. So it's kind of like a form of mass wasting. We talked about avalanches when we talked about mass wasting, and that was when snow flows down a mountainside. Well, this is kind of similar, but it's going to be ice. So this ice is going to be moving downhill as a result of gravity. So we said that glaciers begin as snow. So if this is a mountain, then up here, let's say that it's snowing, and so it starts to freeze and it begins to make a mound of ice up here. Okay, then gravity is going to be pulling that mound of ice down slope. So now let's say that this thing is now down to here and it keeps snowing up here, so it reforms more ice like this. So that eventually you get this big thing of ice that's going to be moving downhill as a result of gravity. Okay, so what do we mean by advancing and retreating? Well, it has to do with the front of the glacier. So here's the front of the glacier. Now, the front of the glacier, this ice can be disappearing because it could be melting, it could be evaporating, or it could be calving, which means that part of this ice just breaks off. So all three of those processes is going to be removing material right here. But material is being added up here. So it all comes down to who's winning. So if it's snowing faster up here than it is melting or evaporating or calving right here, then what's going to happen is that this glacier is going to continue to grow. And then this part here will eventually be down here, and then new material is going to be up here. So we say that the front of the glacier has advanced. It's moving down. But on the other hand, if this part of the glacier is melting faster than what it can be replenished up here, then now the front of the glacier is right up here, let's say, and then we say that it has retreated. But I do want you to remember that a glacier always moves downhill because of gravity. Okay, and then another thing I want you to know is that the top part of the glacier behaves like a solid. So this part of the glacier, the top part of the glacier, is solid, and so it moves like a unit. The whole thing moves at the same speed. But deeper inside of the glacier, it's under pressure. The deeper you go inside the glacier, the more ice is on top of you. and the weight of that ice pushing down on you increases the pressure. And then what you should know is that if you increase the pressure on ice, it will start to behave like a plastic. It will start to flow. So think about silly putty. So if you look at silly putty, it looks like a solid. But if you take silly putty and you put it on a board like this, and you look at it a couple of hours later, you'll notice that it has flowed a little bit. So it looks like a solid, but it's flowing kind of like a liquid. And so we're going to call these things plastic. And so it has to do with the pressure that the ice is under. So up at the top, it's behaving like a solid, but inside of the glacier, it can flow like a liquid. So here is some words that you should know for the exam. So what is glacial plucking, glacial abrasion, glacial incorporation? You should know what glacial scratches are and what causes them. Okay, then you should also know what a horn and a cirque and a hanging valley are. So these are some things that a glacier can make, and you should know what causes them. Okay, then a fjord is where a glacial valley meets the sea. Okay, and then you should know what a moraine is. So that originally a valley that a glacier goes through is going to be V-shaped. So a V-shaped valley is carved by a river. But as a glacier goes through it, it's going to erode material from the sides, and it's going to turn it into a U-shaped valley. And the material that is being eroded off the sides and the material that's being pushed in front of the glacier makes a moraine. And so you can have, at the end of the glacier, you have end moraines. On the sides of the glacier, you can have lateral moraines. So be able to recognize what a moraine looks like and then what created that moraine in the first place. Okay, here's some more words that you should know. So know what a kettle is and what an esker is. So make sure to know those two words for the exam. Okay, some other glacial things would be glacial till. And so this is material that comes out from underneath the glacier. And as you can see, it's got all sorts of different sized particles. Some of the rock is ground down to, it has the consistency of flour. It is so small. And so the wind can pick that up, and that ground material can make these dust storms, and then as it settles back down onto the ground, it's going to make glacial losses. Okay, here is a boulder that is pushed down from further upstream of the glacier, so where the glacier came from. And so these boulders can be very large, and we're going to call those glacial erratics. These kinds of things can be incorporated in the piece of ice, and then if that piece of ice goes out into a lake or into an ocean, as the ice melts, it can drop those rocks onto the floor, and so this is a glacial moraine. Glacial marine. Okay, then what are some things that ice can do? Well, ice has weight. So the weight of that ice can push the ground down. And so, for example, this is a picture of Greenland. And you'll notice that topographically speaking, the mountains are on the edges of the continent of Greenland. And then in the middle of Greenland is a basin. And so that basin was formed by the weight of the ice on top of it. Now, if the ice melts, Then the ground is going to start to rise back up again, and we're going to call that rebound. So just like a spring. Another thing that ice does is it draws its water out of the oceans, so that as the glaciers get larger and larger, the water in the oceans gets smaller and smaller. So that means the level of the oceans drops, and it can expose parts of the seafloor. And then that makes land bridges that people have walked across to get to other parts of the earth. Ice can also change the direction of rivers. So this shows the river drainage pattern before the ice ages in North America. And you notice that some of the river systems actually flowed north. And today, some of those river systems flow south as a result of glaciation. Another thing that ice does is during the ice ages, there were very, very large lakes in North America because the rainfall actually increased during the ice ages in North America. So there were these very large lakes, and for example, the Great Salt Lake used to be much, much larger in the past, but it has evaporated back to what it is today. Okay, so let's take a break, and when we come back, we will talk about the ice ages.